using our notes from 7.1 or 7.1. Okay? Exploring exponential models. The goal is going to be for us to go through these. So identify each function as modeling either exponential growth or tell your neighbor there. So the first one here, growth or decay?
Growth.
Growth. Growth or decay?
Decay.
Growth or decay?
Growth.
Growth or decay?
Growth.
Okay, so we're focusing on our b term, right? If b is greater than 1, it's growth. If b is less than 1 but greater than 0, it's decay. All right, so now if we think about what is our percent growth, well, remember, you're at 1.13. That means you're at 100% plus 13%, which is 113%, which is 1.13. So our percent of growth is 13%. So you always think you have to go back to 100 and explain what percent you're going at. Okay, so like if I was at 100, and I had to get to, what is that as a percent?
30.
30%, what am I subtracting?
70.
70. So my percent decay gives me 70%. That's a 70% decay because I started at 100 and I had to take off 70 to get to 30. That 0.3. That makes sense?
Yeah.
Okay. So what's your percent here? 70. You have 100% and you're adding 70% to get to your 170%, which is your 1.7. So this is 70% growth. This one, you're at 100%. You're taking off 50% to get to 50%, which is 0.5. Okay, so this is 50% decay. Questions there? Okay, that's the first part. Example 2, everyone take a look at number 9. I want you to read through number 9, answer A, B, and C with your groupie there. So the number of bacteria of certain culture increased by 10% every hour until available space is depleted. Only 100 bacteria are present to start the growth. What is the growth factor? What are we growing by? What's our growth factor? Okay, we're growing by 10%, right? And so in order to find the growth factor, we have to take that 10% and add it to 100%. So we have our 10% and 100%, which gives us 110%, which means the growth factor now is 1.1. That is our growth factor. That growth factor we also call which term?
B term.
It's our base, man. Okay?
Growth.
Yep. All right. Write an equation to model the growth of the bacteria. We have y equals, what do we start with? 100. 100 is our A term. Our starting or our initial amount is our A. Okay, the starting amount times our growth or our B, all to the power of x. How many got it? Okay. Now, if I want to predict after 24 hours, how do I do that?
24 for x.
Okay, you plug in 24 for x. Generally, your time is your x variable. It's your independent variable. So in this case, we're going to put the 24 right there, and we end up with how many? About 984? 85 if we round it? Okay. All right. Any questions there? Okay. I want you to take a look at number 11. Read through that one. Do your best to go through it with your groupie there. Very good. So suppose you have $15,000 in equipment for your business. You expect the equipment to be worth 10% less each year. Your friend says the equipment will be worth nothing in 10 years since that would be 100% depreciation. How are they incorrect? Jordan?
Because exponential decay never actually hits 0. It just gets infinitely closer to 0, but it still keeps curving off.
Good. It never actually hits 0 when you're decaying. So this is decay, and I think your friend might be thinking about like linear, right?
Yeah.
I mean, if you're going down 10% every year, that's a linear decrease. you're adding negative 10 every time. And that's not what's happening there. Write the equation. What is our A term?
15,000.
Good, 15,000. Okay, that's our initial value. Okay, what's our B term? Good, it's 0.9 because it's 10% less. Remember, we start at 100% and we subtract 10%. So that gives us 90%, which is 0.9. So that is our
B term.
our B term. And then all to the power of x.
AX.
Now notice on this one it says how much will it be worth in 10 years? Well, since this is 10% less per year, in 10 years, okay, that's second day in a row that's went off, I think. Third day. If that's yours, turn it off. Okay, what is it? Is that a phone?
Yeah, it was my phone.
Okay, can you turn it off?
Yeah, I did.
All right, thank you. All right, and we're going to put what right here? We're going to put that 10. Okay, now if it was saying per month, 10% less per month, and they ask you in years, in 10 years, how many months would that be? 120. So you really have to pay attention to what they're saying here. This is saying per year and how much it will be worth in 10 years. Okay, so it's 10. But if this said per month and then how many it's worth in 10 years, we'd have to multiply the 10 by 12 because there's 12 months per year to get 120 here. Anyway, what's the answer? 5,000.
230 and 18 cents.
18 cents?
Yeah.
Holy moly. All right.
That's a lot
Your
of
friend
money.
was wrong, man.
Your friend was wrong.
All right.
Friend was off by like about
Any questions?
5,230.
Assignment is the mixed side all. A few quick comments. First, number 14, I would figure out that equation and then use my graphing calculator in the table to help me out. Otherwise, when you try to find this answer, you're going to need to use guess and check or logs. You'll know why once you get there. I would use the table feature in my calculator, which means you may have to use the table set to get it to where you want it to be. That's number one. Number two, on these right here, numbers 10, 11, 12, 13. Number 10, they're telling you to take this equation and use this domain. That means you're making x 0, 1, 2, 3, 4, and 5.